Imagine this. In a distant future, so far removed from our present that all of humanity's struggles have faded into myth, we have transcended our limitations. Earth, once the center of everything we knew, has become nothing more than an ancient cradle, a quiet relic of where it all began. Humanity is no longer confined to a single star system. Our descendants have spread across the entire Milky Way, from the blazing galactic core to the furthest reaches of its spiral arms. Trillions of lives exist in harmony, thriving in an age where science, art, and knowledge have reached unimaginable heights. And then, something happens. A signal. Not from a nearby star, not even from within our galaxy, but from another galaxy, another civilization, another intelligence. For the first time in history, humanity realizes we are not alone. Messages begin to travel across the cold, empty void between galaxies. Mathematics is exchanged, the laws of physics are compared, philosophy and art are shared, blending together to spark a new golden age of understanding. Separated by millions of light years, the two civilizations begin to grow closer, not in distance, but in knowledge. And then, a decision is made. They will meet, no longer through signals or distant ideas, but face to face in the vast darkness of intergalactic space. Great ships are built, not in a single lifetime, but across generations. Entire lives are lived and lost in pursuit of a journey that no individual will ever see completed. Thousands of years pass, and in the deep, inky blackness between galaxies, the two vessels finally arrive. A moment destined to be written into the history of the universe. Two individuals emerge, drifting silently into the void. No sound, no air, only the infinite silence of space surrounds them. They reach out, closer, closer. They touch, and in an instant, a blinding flash consumes them both. Gone, without a trace. Nothing remains. The massive ships stand frozen in shock, watching in silence, unable to comprehend what just unfolded. What just happened? How could two advanced civilizations, capable of crossing the vast emptiness between galaxies, fail to foresee such a catastrophic outcome? The answer lies in something simple and profoundly hidden. The two beings did not die by accident. They were never meant to touch, because they were fundamentally different. One was made of matter, the other of antimatter. At first glance, antimatter might sound like science fiction, something exotic, distant, or even imaginary. But in truth, antimatter is very real. It follows the same laws of physics, the same structures, the same rules as ordinary matter. And yet, it is its perfect opposite. For every particle that makes up our world, electrons, protons, quarks, there exists a mirrored counterpart, identical in mass, identical in behavior, but opposite in charge. An electron has a negative charge. A positron, its antimatter twin, carries a positive charge. A proton is positive.
An antiproton is negative. Two reflections of the same reality, two halves of a perfect symmetry. But this symmetry hides a deadly truth. When matter and antimatter meet, they do not merge, they do not coexist, they annihilate, instantly, completely. Their entire mass is converted into pure energy in a flash of light, a release so violent, so absolute, that nothing of the original particles remains. This is not destruction in the way we usually understand it. It is erasure, as if they were never there at all. And that is exactly what happened in that silent void between galaxies. Two beings, each a masterpiece of their own civilization, reached out in curiosity and triggered one of the most fundamental reactions in the universe, a reaction written into the laws of reality itself. But this raises a deeper question. If the universe allows both matter and antimatter to exist, if they are born from the same laws, the same equations, the same symmetry, then why is our universe made almost entirely of matter? Where did all the antimatter go? And more importantly, why didn't either civilization realize the difference before it was too late? The truth is unsettling, because the universe does not easily reveal its secrets, even to those who believe they understand it. So how could this happen? How could two civilizations, advanced enough to cross the vast emptiness between galaxies, share their science, their mathematics, even their deepest understanding of reality, and still miss something so fundamental? It seems impossible, and yet it happened. Because the universe does not simply reveal its truths, it encodes them. It hides them behind patterns so deep, so elegant, that even the most advanced minds can mistake them for completeness. At the heart of this mystery lies a quiet principle, a principle so fundamental that it shapes every law of physics we know: symmetry. At first glance, symmetry feels simple. It is the idea that something remains unchanged when transformed. Rotate a perfect sphere, nothing changes. Reflect a pattern in a mirror, it still makes sense. Shift an experiment from one place in the universe to another, the outcome remains the same. But this simplicity is deceptive, because symmetry is not just a visual idea. It is not just about shapes or patterns. It is woven into the very fabric of reality. In fact, modern physics tells us something extraordinary. The laws of nature exist because of symmetry.
There is a deep and powerful connection between symmetry and conservation laws, a relationship so precise that it can be expressed mathematically. If the laws of physics do not change over time, energy must be conserved. If they do not change across space, momentum must be conserved. If they do not change under rotation, angular momentum must be conserved. These are not separate rules. They are different faces of the same underlying truth. Symmetry governs what can happen and what cannot. It defines the boundaries of reality. But here is where the story takes a darker turn, because symmetry does not only reveal, it also conceals. The equations that describe matter and antimatter are almost perfectly symmetrical. To a physicist, they are nearly indistinguishable, two sets of rules that mirror each other with astonishing precision, which means that an antimatter civilization, developing independently somewhere else in the universe, would discover the same physics. They would write down the same equations. They would observe the same behaviors. They would build the same understanding of reality. Everything would appear consistent. Everything would appear correct. And yet, everything would be fundamentally incompatible with us. This is the hidden danger of symmetry. It creates a universe where two completely different physical realities can evolve side by side, believing they understand the same truth, until they interact, until the illusion collapses, until symmetry is no longer enough to hide the difference. And by then, it is already too late. This is why neither civilization recognized the problem, because nothing in their science told them they were different. Nothing in their equations warned them. Nothing in their understanding of the universe revealed the truth. The laws of physics did not lie, but they did not tell the whole story. They were symmetrical, and that symmetry concealed a fatal difference. But if symmetry can hide such a profound truth,
then perhaps it is not the whole picture. Because when we look at the universe around us, we find something unexpected, something imperfect, something broken. The universe is not perfectly symmetrical, and that imperfection is the reason we exist. If symmetry is so fundamental, so deeply embedded in the laws of the universe, then a question emerges that is both simple and terrifying. Why does anything exist at all? Why is there something instead of nothing? Because if the universe had followed its own rules perfectly, we would not be here.
In the earliest moments after the Big Bang, the universe was a place of unimaginable energy. Temperatures were so extreme that the distinctions we now take for granted, matter, forces, particles, had not yet fully separated. Everything existed in a state of near-perfect symmetry. For every particle of matter created, there was a corresponding particle of antimatter. Perfect balance, perfect order. A universe that, in theory, should have canceled itself out completely. And if that balance had held, every particle would have met its opposite. Every interaction would have ended in annihilation. A blinding sea of energy, and then nothing. No atoms forming, no stars igniting, no galaxies assembling, no chemistry, no biology, no observers, no story. A silent universe, perfectly symmetrical and completely empty. But that is not what happened. Somewhere in that first fleeting fraction of a second, something changed. Not dramatically, not violently, but subtly, quietly. A tiny imperfection appeared in the fabric of reality. For reasons we still do not fully understand, matter gained a slight advantage over antimatter. Not by much, not even close. For every billion pairs of particles and antiparticles, there was just one extra particle of matter. 1 in a billion. A difference so small it almost seems meaningless. But in a universe governed by annihilation, that tiny difference was everything. As the universe expanded and cooled, matter and antimatter began to collide and destroy each other. Again and again, wave after wave of annihilation swept through the early cosmos. Pairs vanished into bursts of pure energy, over and over, until almost nothing remained, except that tiny excess, that one extra particle in a billion. It survived. And from that survivor, everything else followed. Every atom that would one day form stars, every star that would forge heavier elements, every planet that would orbit those stars, every molecule, every cell, every living being. Every thought you have ever had, every question you have ever asked, all of it traces back to that microscopic imbalance, that flaw, that break in symmetry. In a strange and profound way, we exist because the universe is imperfect, because its laws, while elegant, are not absolute, because something, somewhere, allowed symmetry to fail. And in that failure, reality began. We began with a meeting, a moment of hope. Two civilizations reaching across the greatest distance imaginable, only to discover that the universe had drawn a line between them, an invisible boundary, a rule they could not see, a truth hidden in symmetry. And from that moment, we followed the thread deeper, into antimatter, into the laws of physics, into the realization that reality is not only shaped by symmetry, but by its failure. Because everything we see, everything we are, exists in the aftermath of a broken perfection. A universe that should have erased itself, but didn't. A universe that chose imbalance over emptiness, structure over symmetry, existence over nothingness. But here is the part we often forget.
This process did not end in the distant past. It is still happening, right now. The universe is expanding, stretching space itself, cooling slowly but relentlessly. And as it cools, the conditions that once defined reality continue to change. Energy scales drop, forces separate, new behaviors emerge. And hidden beneath all of this, there may still be deeper symmetries, undiscovered, unbroken, waiting. Far beyond the reach of our current experiments, there may exist entire layers of reality, governed by rules we have yet to uncover. Supersymmetry, new particles, new fields, possibilities that linger just beyond our understanding. For decades, physicists have searched for these hidden patterns. They have built enormous machines, like the Large Hadron Collider, to probe deeper into the structure of matter, to look for signs that our current theories are incomplete. So far, we have found nothing definitive. No clear evidence of supersymmetry, no hidden partners waiting in the data. Only the familiar particles of our known universe. And this has led to doubt. Some now wonder if symmetry has misled us, if we have been chasing a beautiful idea that may not reflect reality. But others are not convinced, because symmetry is too powerful, too elegant, too deeply embedded in the fabric of everything we understand. And so the search continues. Because if history has taught us anything, it is that the universe does not give up its secrets easily, and when it does, it changes everything. So, as you look up at the night sky, consider this. What you see is not the final form of reality. It is a temporary state, a phase, a moment in an ongoing transformation. The laws of physics you trust may not be eternal. The forces you believe define the universe may not be the last. And somewhere, in energies far beyond our reach, the next symmetry may already be waiting to break. When it does, it will not just change the universe, it will redefine it. And we will either adapt or become part of a story that continues without us. Because the universe is not static, it is not complete, it is not finished, it is still becoming, and we are living inside that process.